All right, so these are the groundwater models. These only operate on distilled water, which is located at the taps, the white taps on either side of the classroom. There's a maximum of 50 liters per day available to us, so usually the day before we fill up all of the water bottles, the extra 4-liter jugs, as well as 2 buckets, just to make sure we have a full supply. We do the same thing at the end of the day. Once we're done packing up, we try and fill up everything. So for the next class to come through, especially if they're back-to-back labs, we can get all the water we possibly can out of the system, because if they run dry, kind of halts what we can do with the models. Couple of big things to note: if the water level drops, or if the tank ever runs dry and the water level drops, the results the students are going to get out of the models are going to be really flawed, as well as you're going to have to run a lot extra water through the model in order to flush the dye out. If you leave the dye in the model, eventually it will stain the model. So we do have a couple of spots where you can see there is coloration in the aggregates. Just things we need to be aware of. If they're doing their job properly, as they're doing the labs, the models self-flush fairly well, and should happen all within the timeline that we have given for the labs. A big thing to notice with all of the models is the nozzle that comes out of the stopper needs to be below the top level of the ground line, so below the top of the bottom of the sand. That way the water table doesn't bridge out over the surface and cause a bypass, which will actually draw your dye plume up to the surface and run along the surface. Most of the models should be set so that is the case, but if you notice when students are playing with it, sometimes they'll play with the tip of the nozzle while they're waiting to put the next one in, and they'll push it in. That can be a problem as well. Again, they'll get bad results. Once they're going, they need to be really aware of the water level. We have 2 water bottles per group, so that as soon as this is getting down to a quarter left, they should be thinking about swapping it out for a new one and then filling up the other water bottle. Just that way there's always a continuous flow. If they're doing that, then they are going to have fairly strong repeatable results between each model and between each class. Over the last few years, we've discovered that plugging the artesianal well for the first part of the lab will actually drive the dye plume across the model in a nice uniform fashion. What we found was when this was open, we would get bypassing through the artesianal well and out into the lake or river channel. Especially once you open the lake and river channel up, you would get an extreme bypass where you would basically just get a stuck dye plume and nothing would happen. And again, once that happens, you do have to sort of really pump a lot of water through to flush it through. Mm-hmm. So we've got plugs for all of them. I think on 4 of them, they're basically just the syringes with a tip on it. We've got 1 regular tip. They need to be stuck in there. When we run through the model later, we'll play with that and you can actually see how much of a difference it makes. The valves on all of these are really sensitive. There's kind of like a single degree is like basically closed to a good flow rate, and then another degree is like wide open, and that's kind of right in the middle of their swing. So they need to play with it to get the right flow rate. Generally, the right flow rate can be judged off of the lake. The lake should hold a constant level if they've got the lake valve open the right amount, and you will get flow through that lake circuit, but it won't drop. If it starts to drop, it's too far open. And obviously if it stays up real high, then it's not open enough. That's for when you get to that point in the actual event. We have 2 types of syringes for use with these models. We have this one here, which is for injecting the dye. We mix the dye We premix the dye for them. We usually give them a couple of colors, just so it's not all the same. That helps when they're doing additional points. Get them to remove the hose before they suck it up with this, and make sure that they're aware that if they force this really hard, as Jorgen found out, it'll actually blow the line off and spray dye all over the place. So if it's really, really hard to push, they should just go slow. Shouldn't try and force it, because it will spray dye everywhere. And a lot of people don't want to be covered in food coloring. This syringe is used for extraction on only the pumping wells, which are the ones that have the large black part on the bottom. This can be done simply by putting the syringe on the top, pressing down firmly, and then slowly drawing up. When you have your contrast dye in your piezometers, you can actually watch the cone of depression as it forms as you're drawing up. And anytime you draw up, the spent water goes into the bucket and not back into the model. You should never force water in to any of the wells or the piezometers, and you should, in all instances, try and avoid extracting water through the piezometers, which are the smaller ones. We have a couple of models which have been damaged over the years by people pumping too hard through the piezometers and drawing in sand into the piezometers, which are going to give you false readings.
So there's two pumping wells.
So there's two pumping.
This one's not.
So yeah, this one's mislabeled. These are piezometers. These are pumping wells. This is just a channel for the artesianal well, which exhausts into the lake. It should be the same on all of them. Dyes injected that get stuck with careful pumping at either of the pumping wells. Typically you won't get dye stuck in the artesianal well, but you can get it stuck here. Careful pumping at the pumping well will help speed up flushing the model out. But again, if they're drawing it up too fast, it's just going to suck air down the piezometers, and they're not really going to get anything. So just make sure that they're going slow when they're drawing out. Other than that, that's the basics for how the models function. Once you inject the dye, it's usually a good idea to have a piece of paper towel around the base, because the dye will leak up a bit when you're trying to pump in. So you just slowly inject a dye pack that you can see how it pumps out and pumps up. You just slowly inject a dye plume. Usually something about size of a quarter to a toonie is good. And then that's when you start your timer. Once the timer's running, they usually draw the first plume and then draw the propagation. It's also quite easy for them to see on the other side the dye plume. So we do suggest that they do use the back side as well for using the paint pen. When you have your extraction from either the wells, they'll be able to see the dye move. It's kind of a double-edged sword. The stronger the dye concentration, the easier it is to see the plume. If they have a really weak dye, by the time it gets to here, it becomes really hard to see. But the problem with that is that if it gets stuck with a really strong dye, you potentially can stain the models. So just something we have to be aware of. When you are going through the actual labs, and you do remove this, you will actually see a fairly strong plume of dye come out, especially if you've got dye in the artesianal well. It might be something that you guys can get sort of suggest to them as part of the third part, make your own model. But other than that, that's kind of the basics of all of the models. Once they are running, they have to be kept running, and the groups are not done until the models are as they were when they started. So there can't be any dye left in it anywhere. No one in the group is allowed to leave until the benches are wiped down and all of the wastewater is disposed of and all of their water bottles are refilled at the very least. The last group is going to be the group that's going to be responsible for making sure that the fresh water buckets are full as well as their cleanup. So that's kind of the punishment for being the slow group, which is usually the people who weren't paying attention and let their model run dry. Other than that, we can go through the lab and you guys can get an idea of how it all works. Typically what we do is when they're flushing the models, the last bottle of water that they end up flushing through the model, they're usually going to do they're going to flush the model so they're clean, and then once they're clean, we're going to do one more bottle, and it's going to be about a 30% bleach solution, and we're basically just going to run that through until it stops running, and then the models get put away. That's just to ensure that it helps remove any dye that might be still mobile in the model, as well as it prevents any bacteria or mold forming inside the model. So that's the last group, last go with it. We have a fresh thing of bleach right behind us, so we should have more than enough for everyone to use. And again, that's just basically 30% in one bottle, run that through, and then finish the cleanup. For one of these containers, we usually do around 20 drops. Gives us a nice strong concentration. We will get more dye to make sure that we have enough. Do not use the tap to fill these. That generally will make a giant mess. We have a little container here. You fill it and then slowly add it. Generally you want to see a mix that it makes it hard to see the bottom of the container. If it's not dark enough, you can add more dye. It's really dependent on each dye. Some dyes you need to add a lot more, some less. Usually the darker the dye, the easier it is to get right, but a nice strong dye. You take your, if you're the first person, extract a little bit and just shoot it back in to mix it up, make sure it's nice and evenly mixed. And then take one full 20 cc or 30 cc syringe. I'm getting a little bit out of there. And then you can affix your hose. Warn people that they are going to get covered in dye. So prior to the lab, wear bad. Don't wear nice clothes. Is generally a good thing. Is carefully put the syringe into all the piezometers and very lightly inject a little bit of contrast dye. Let's see it. And kind of just inject a little bit at the top and then just sort of wiggle it down with the tube. This just allows you to see the water table a little bit better. You only need a little tiny bit. Don't let them fill it to the very bottom, because you will, as the model is moving, you'll actually get leakage at the bottom. They just need to touch in and then they can just wiggle it down. So once we get our contrast in the model, reload this. Again, tip below sand surface. Crack open your valves. This one's already open. This one can be wide open. It's not going to hurt the model. As far as the results, it's the lake model. that needs to be more carefully metered. So once you've got that done, having a wet paper towel around the base of this when you inject your dye, your furthest, closest to the water bottle injects down into the artesianal well. The middle one injects right about here, and the red one injects into the coarse wedge. So we go into the middle one. Take your paper towel, carefully wrap it around the base. This will just catch any dye that backs up the top and keeps it from running across the surface. Inject your dye, nice strong patch. Carefully remove this with the paper towel. It doesn't flick dye at everyone. Start your timer. Obviously draw your plume and sit back and watch. Every 5-10 minutes they should take a look and see where the plume moves. As you can see, the water level is up above it.
Right.
So you'll probably, we always get a question about that every year.
Mhm.
So just tell them they can use that as a piezometer, which will tell them, again, if, I mean, there's not gonna be a huge difference here and here,
Mhm.
but there is gonna be usually a fairly different, fairly noticeable difference, not huge difference between either end.
Mhm.
So you can see the flow rate, how much bypass you get with the artesianal well. You can start to see it coming up the plume.
Right.
The actual model is quite slow compared to the other ones. They all do run at a different speed.
Mhm.
So there are a couple of slow ones. I think number 5 is the fastest because that's the one we've.
One.
I think 5's over there. That's the one that has been fully rebuilt.
Got it.
Starting to come up. But yeah, you can see this will just pretty much sit there now for any period of time.
And how do you, so for flushing it, you basically just open up the valves and let the water flow through it?
Yeah, that's part of it. Generally, I try and ask the TAs to do this and not students.
Okay.
The fastest way to flush it is have one of the you come along and slowly extract the dye out of the piezometers. But as you can see, the ones that are damaged, you're sucking up a lot of sand,
Right.
which is why I would rather have you do it than the students.
Right. Yeah.
This
Your
just
sand bulge.
Yeah, that just sort of speeds up the ability to get the dye out. I mean, there's not really much we can do with this model. This model needs a rebuild. When it comes to these guys, typically what I do afterwards is I will force water down and try and blow that sand back down.
Right.
But I definitely do not suggest students do that.
Yeah.
You see how the plume is starting to really follow the contour.
Mm-hmm. Native to your piezometer.
And if you're lucky and you get a model that gets stuck right here, with careful extraction through the piezometer, you can get a large amount
Mm-hmm.
of the dye out. But again, go really slow and a lot of force down to seal the rubber stopper
Right.
against the top. What is usually a better way of doing it for the students, they can pretty much go as hard as they want, pulling through the pumping wells,
Mm-hmm.
and that'll just draw it across and up. That can also help a stuck model. So also when they're going, and this is transiting in underneath the pumping well,
Mm-hmm.
one thing that I found was always interesting to see was that once it's underneath, you'll actually, if you start pumping, you'll actually watch the plume just sort of and get sucked up.
Mm-hmm.
Pulling it like this will basically just suck all of it out. Similarly, when it gets over here, if they turn on the lake, the same effect will happen. It'll get drawn up into the lake.
Right.
So a very deep contamination that's literally running along the top of a confining layer will get drawn up into the lake.
Okay.
It'll be pretty clear because it'll just all of a sudden, even if there's a slight contamination, you'll be able to see the dye swirling around inside the lake
Mm-hmm.
fairly easily. And if they want to see it clearer, they can just take a piece of white paper or something like that and put it behind, and it becomes even more clear. Like there's a slight amount of blue dye in that water right now.
Mm-hmm. So just a kind of a general workflow for flushing it, you would recommend having the TA do the delicate pumping out of the piezometers, and then the students kind of go through this pumping well,
Yeah,
squeezing process.
and a huge portion of all of this is time. They will have to sit and just be patient.
Mm-hmm.
If they're on the ball and the model's working as it should be, and they're working properly, the lab should not take longer than 2.5 hours.
Mm-hmm.
If they're not paying attention, the bottle runs dry, or they're not doing things in the right stages, it definitely can take longer.
Mm-hmm.
Especially the nozzle placement's key, and then having this not just in, like you can stick it in there, but you can see how it's actually
Right.
welling up. You have to have it in there and press down,
Mm-hmm.
so it's actually stopping the flow.
Got it.
And then you actually get a pretty strong flow gradient across. And once it actually reaches the end, you will see the dye sort of welling up on this side
Mm-hmm.
and flowing into the end container or the end tank.
So how would we fix it if the nozzle, if they put the nozzle in the wrong, like if the water table dropped from their improper nozzle placement? Like how would we fix that?
Realistically, the only fix for it is just filling it back up
Right.
and basically pumping water through it.
Right.
The problem is that once it drops, the whole water table will drop.
Yeah. So if you
And
split
the
a ton
water
of-
table won't drop evenly. It'll kind of drop at this end first,
Yeah.
and then kind of go back up to where it was, and then resettle.
Yeah.
I mean, you can.
It's gonna
you
mess
can
up all the results.
yeah, all of the results are going to become kind
For
of
sure. Yeah.
really invalid because not only that, but that drop
Yeah. The gradient's gonna change.
will stop the water flow rate across.
Mm-hmm.
So
Yeah.
literally like that, you'll have whatever the 5, 6 minutes, 10 minutes that they weren't paying attention. there will be no flow rate. So all of a sudden, what was supposed to be a 30-minute flow rate now is a 60-minute flow rate,
Mhm.
and the numbers they get out of it are going to be, totally wrong.
Right.
To help speed it back up, filling the top trough with water and getting the water table back to where it should be will help a bit, but there's no real recovery from it. That's more of just having the model kind of catch back
Yeah,
up
for
and
sure, yeah.
flow evenly again, so they don't get sort of into a position where they've got this giant lump of dye right here.
Right.
You're an hour and a half into the lab, and they haven't seen anything because they're only on their second bottle, which they've let run dry
Right.
for 10-15 minutes, which happens to at least 1 or 2 groups per lab per year,
Mhm.
Right.
where they're just not paying attention.
Yeah.
And so how many bottles will they go through in the lab period?
If they do it properly, they'll probably go through anywhere between 4 to 7, depending on the model.
Okay.
Number 5, I think, is the fastest. It usually goes through about 4.
Right. There's not a lot of extra water available, it seems like. You said there's only 50 liters.
Yeah, so that's why
And
we
there's like only like 35 liters would be used in the lab, kind of.
theoretically, yes.
Right.
I mean, there's also always spill. There's always a mess to clean up, and we always try and have a little bit of more than we need.
Right. Right. So they always have 2 on them, and then once they replace it with the second one, then they fill back up the first one with
Yeah.
these.
So
larger bottles.
they should always have someone basically on water detail.
Right. Yeah. There's enough free time that they should be able to.
Yeah.
Yeah.
One person usually records, one person usually draws on the model.
Right.
And, the person recording is kind of the one who should be sort of overseeing it,
Right.
because they're the one watching the clock and watching sort of what they're dealing with.
Right. Yeah. Gotcha.
And yeah, you can see it fairly clearly on the backside too, if you guys want to have a look. What you also will see sometimes on some of these models is a big difference between one side or the other as far as the quality of the plume. You can have a real soft plume on this side, but on this side you can have a really strong, vibrant plume.
Should they maybe draw the propagation on the other side and then compare it?
They need to kind of pay attention and go sometimes with both sides.
Right.
Yeah, at this point, I usually always just kind of, as a demonstration on one, would say, you can kind of see how
Mhm.
it gets drawn up from
Totally.
Yeah.
from both sides.